So now matter on to integration. Let's quickly talk about the basic of integration. Many of us are familiar with it, but for the sake of those who are not familiar at all or did not do it in their secondary school, so let's quickly talk about it. So if you have integral of ax raised to power n, integral of ax raised to power n, are we together? So it becomes, since the a is, these are variable here, since the a is a constant, the a comes out, it becomes integral of x raised to power n dx. Dx must be added. Are we together? Now let's differentiate this. Let's integrate rather. It becomes a. If you want to integrate x raised power of n, x to the power of n, you add 1 to the power, then divided by the total power you now have. That's the rules. Then you add your constant. This is the answer. This is the rule, the basic rule of integration. Take note of that. So for instance, if you want to do, probably we have a question that says integral of what? 2s cubed dx. So what you are going to get, 2 will come out because it's a constant. Then you have your s cubed dx. Now let's integrate. This becomes 2 open bracket. If you integrate s cube, you get s cube plus 1 over what? Q plus 1, right? Plus c. Once you are integrating, once you have done integration, even though you have not simplified the answer, always add plus c. So this becomes 2 into what? X raised to power 4 divided by 4 plus c. So we have s raised to power 4 divided by 4 plus c. Now 2 here, 1, 2 in 4, 2. So this becomes what? X raised to power 4 over 2 plus c. So that's the answer. X raised to power 4 over 2 plus c. So those are the basic rules that we need to be familiar with. Now, let's move to some aspect now. Okay, before we move to another aspect, let's quickly solve a few questions on the basic rule that we've done. Now, let us integrate x raised to power 4 plus x minus 1 dx. Now we are dealing with indefinite integral. Now what do I mean by indefinite? There is no interval. There is no limit. Assuming there is interval, they can put 0 here and 1 here. So once you are done with your integrating, you substitute the upper limit into your answer. Then you subtract you substitute your upper limit, then you substitute your lower limit into that same answer. Then you subtract the lower from the upper. That is if it's definite that we are given limit interval, we don't need to add plus c again because we are going to get a definite value. But if it is indefinite like this, there is no limit, then you add plus c constant to your final answer. Now we can split this guy. You can solve it directly, no problem. You can begin to integrate directly without splitting. At the same time, you can split into integral of x raised to power 4 dx plus integral of x dx minus integral of 1 dx. You can split each because it's addition and subtraction. The only time you cannot split like that is if it is multiplication or division. Since it's addition and subtraction, then you can split each to their various steps. So now, if you integrate this guy, we get x raised to power. Don't forget, you add 1 to the power. This becomes 5 over what? Over 5. Plus, if you integrate this, there is 1 there already. You add 1 more over 2 minus. If you integrate 1, that one normally doesn't have x, it doesn't contain x. You can write it as 1 times x raised to power 0. So if you add 1 to this one over 0 plus 1, this becomes 1 times x raised to power 1 over 1. And that becomes what? X. So if you integrate a constant, you get the constant multiplied by the variable you are integrating with respect to. Since you are integrating with the x, so and the constant is 1, so the answer is going to give us 1 times x. Assuming this is 2, we are going to get 2x since that 2 is a constant. So if we are integrating with dy, maybe this is 1 dy, we are going to get y. So this gives us what? X. So that's the answer, but we can find the LCM. The LCM is 10. 5 in 10, 2. 2 times x raised to power 5. We have 2x raised to power 5. 2 in 10, 5. 5 times s squared plus 5s squared minus this over 1. 1 in 10, 10. 10 times x plus what? 10x. So that's that for that. There's no big deal about that. That's what that is. So now plus c. You must add your constant. So that's your answer now. Don't forget the constant is very important. So there's something I should have told us from the beginning. When we are talking of integration, we have various methods of solving integration, of which you need to be familiar with. We have the basic one I've told us earlier, which we have done. We have integration by use substitution, integration by part, integration by partial fraction, integration by trigonometry substitution, and we have more than that. So we also have the one that we use long division for. So now let's quickly treat. We also have some rules that guide integration. Some rules. For instance, okay, let's talk about the substitution of variable. The one with substitution of variables, which is popularly known as u substitution because we make use of u. You can use other letter, there's no problem, but we normally make use of u. You can use v, you can use w. For instance, if I tell you to integrate, maybe integral of 1 over x ln x dx. Now, if I want to integrate 1 over x ln x dx, now the best thing to do is that you bring another variable in, let u be equals to ln x. Why am I doing that? Because I know that if I should differentiate ln x, it's going to give me something that's going to cancel out this x. Then at the end of the day, the work will be easier. Now, if I say let u be ln x, then du over dx, if you differentiate ln x, what do you get? You get 1 over x, right? Whenever you have a lane function, if you want to find the derivative of a lane function, just differentiate the inside. If you differentiate x, which is the inside, you get 1. Then divide it by that inside. That's the answer. Derivative of the inside divided by the inside. That's the answer of a derivative of a lane function. So now let's make ds the solid of the formula. If you cross multiply, ds will give us what? X du, right? Now I write this question back. This question now is what? Integral of 1 over xu. Why is it xu? Because we already said let u be ln x dx. But what's our dx? X du. X du. So x cancel x. So the question becomes integral of what? 1 over u what? Du. And we are familiar with this standard integral. If you integrate 1 over u, what do you get? You get ln u. Isn't it? So our answer now is ln u plus what? Plus c. But don't forget, the original question is in function of x. Now your answer is in function of u, so you have to substitute u back. So you already say let u be ln x. So since your final answer is ln u, what you get now is what? Ln x. Ln x plus what? Plus c. So this is the final answer. You bring u back since u is ln x. I'm using absolute value because x can be negative, we don't know. And ln of negative value is undefined. So that's why I'm using absolute value. So this is the final answer for that. Now, let me give you some rules too. Some rules like if you have something like integral, this is not what I want to do now is it's not use substitution. It's like a standard. This is it. If let me say the integral of f of x over g of x dx, the integral of this guy is equal to ln g of x. The integral of this guy equals to ln g of x if there's a condition that will make it to be equal to this. If g prime of x equals to f of x. What's the meaning of prime? That is if you differentiate. So the integral of a rational function I mean by when you have a fraction, equals to ln of the denominator if the derivative of the denominator equals to the numerator. If you differentiate the denominator and the answer you get is same thing as the numerator, then the final answer will be ln of the denominator. Now let's apply it. For instance, if I have integral of, let's say, 2x over s squared plus 1 dx. Now if you differentiate s squared, here you can also use substitution. Like use substitution, we apply use substitution in something like this. But you just make it fast because it's a standard rule in integration. If you differentiate s squared, you get 2x. S squared plus 1. If you differentiate s squared, you get 2x. If you differentiate 1, you get 0. So the derivative of s squared plus 1 is equal to 2x. Now because by the time we differentiate this, it gives us the numerator, exactly the numerator. Then the final answer equals to what? The final answer equals to what? Ln s squared plus what? Plus 1. then plus c to give you the ln of the denominator. It's a rule you need to understand very well. So please take note of that. But there are some cases that the question will not look like that. So we have to. So now there are some cases that it will not look like it. It won't look like it at all. But what you need to do is to manipulate. For instance, let me give us a question. Let me give us a question. Let's say, let's say here we have integral, integral, we have integral of s cube plus s squared dx. So this one give us 6s squared plus 4x. Now I want to apply that standard rule. Now listen, this is a question. Now if I differentiate the denominator, I will have, if I differentiate s cube plus s squared, I will have 3s squared plus 2x. It's not equal to this, is it? Assuming it's equal to it, I would have said my answer is ln of this plus c. But it's not equal to it. What am I going to do? I can manipulate this to look like integral. What is common to these two? 2 is common, right? Now bring out 2. What do you have left here? 3s squared. What do you have left here? 2x. Over what? S cube plus what? S squared dx. This 2 is a constant. It can come out. Since it's a constant, you can bring it out. 2. Are we together? So I have to rewrite it again, but I just say let me clean it. Now, if you differentiate this, s cube plus s squared, you get this. It's exactly same thing as this. Then your final answer, don't forget there is 2 outside. Your final answer will now be 2 multiplied by what? Ln of the denominator. S cube plus s squared plus c. So we can see how I found my way out of there, so that I won't be stressed myself. You can do something else and you still get your answer, but this is just like law that is allowed in integration. It is allowed every time, everywhere. Just apply it, then you find your way out and you are done. No wasting of time. Now let's do one more question before we call it off. Let's say I'm looking for one more question before we are done. Now see this one, integral of tan x dx. Integration of tan x dx. Now to make work easier for you, just have to change it. You know, tan x is same thing as what? Sin x over what? Cos x, right? Dx. Now if you differentiate cos x, what do you get? You get minus sin x. It's not same thing as sin x, isn't it? Is it same thing? No. So now you are going to do something here. You are going to change the question to what? Integral of minus sin x over minus, okay, sorry for that. Actually it's correct, but there is a way I should have written it to make it better. Integral of minus 1 over minus 1 multiplied by sin x over what? Cos x dx. No, minus 1 over minus 1 is 1. I've not changed anything, have I? No, I've not changed anything. Minus 1 over minus 1 is 1. So this is the same thing as this. So here it becomes integral of, now this minus 1 here, this minus 1 I can bring it out. So integral of 1 over minus 1, minus 1 times sin x minus sin x over what? Over cos x. Then you have your what? Your dx. Do we see? Like the minus 1 down here, I brought it out. Normally 1 is always everywhere. But 1 times this give us back. So there is 1 here. So when I brought out this minus 1, do we get that? So I have my minus 1 attached to here. In fact, there's no problem. You can even say you bring out 1 here, then you leave the minus left. There's no problem about that. So this gives us 1 over minus 1. That's still minus 1. So minus 1, leave it as minus sin x over cos x dx. Now, if you differentiate cos x, what do you get? Minus sin x. So the answer is equal to, now don't forget there's minus outside. Since the derivative of the denominator give us the numerator, so now our final answer will give us what? Ln of the what? Denominator. Ln cos x plus c. That's the answer. So that's that for that. Thanks for watching. Don't forget to like and subscribe. We'll continue in the next video. Also share the video with your friends. Thank you.